Hi, I'm Gil. Think about automated tests. Where would we be without them? They save us a lot of time, but they come with a big cost. So the horrific truth is we're kind of responsible to this accumulating cost. Hi, I'm Gil Zilberfeld. I'm a trainer and a consultant, and I work with developers and testers who want to make software better. I blog on my site and I put on videos on YouTube around these topics, along with the topic I'm going to talk about today. Okay, so Frankenstein tests. I want to show you something really scary. So this is a playwright test, and it passes. It's kind of a monster. I wouldn't want to maintain this, would you? What is it that makes it a monster? Well, a couple of problems here. First of all, it's too long. Obviously, it fits more than my screen. It does too much, too. But I want to focus on the gut reaction that you got when you looked at it for the first time. We mix different languages in these tests. The first one is, of course, the programming language. It's JavaScript. And that's okay. The second language is Playwright. I'm using Playwright as a tool, so there's a lot of locators and divs and selects in there, and some XPath as well. What I don't see there is the domain language. I don't understand what it's doing, what it's about, what it's testing. So I want to show you the page that it actually runs. So this is the page, and as you can see, it has vacations and flights and tours, and we didn't see any of that in the test itself. So our tests become like a patchwork of things, of languages, of tool language, the test language, the domain language, a Franken test. So how did we get here? First of all, looking at these tests, we're kind of used to tests looking like that. We're using sometimes tools to generate them. I generated that with Playwright code generation. Sometimes we use AI tools to generate tests for us. But problem is that, of course, the code that we generate for the test is for using the tool. And the generator doesn't have any context of what it's running. But it's not only the tools that are the problematic. We are also responsible for that because we're copying and pasting a lot of this test code around. We're spreading the disease as well. So you're probably asking, what's the problem here? So the tools or us writing this, we're usually focused on writing or generating the tests in order for it to run. But we're forgetting that the main cost of tests are not writing them, is maintaining them. These tests are not readable. They are open to interpretation because everybody sees something else in there. They're hard to maintain. They are hard to debug. They are hard to understand. And when we get to actually touching them and editing them, we kind of beware of what we're trying to do. We're trying to not make big changes because it's risky. We might break something that we don't understand. We're very careful, but we still make mistakes. Sometimes it gets to a point where we would rather regenerate the tests, and then that comes with a risk of its own. Maybe it's not completely the same test, and we wouldn't know. Maybe the test was failing, but by regenerating it, we're kind of hiding a bug in there. Now, that's for just one test. Like, take that test and multiply it by the number of tests that you have, by the number of platforms that you have, and by the number of tools that you have. Like, you get many tests that takes a while to maintain. Now, another thing happens when we have a lot of maintenance time on tests. We consider them as a burden rather as value. When that happens, we write fewer tests. So what happens is that instead of having a lot of automated tests to save us time, we have some tests that take a while to run and maintain. It slows us down, and we write fewer tests, and therefore we write the rest manually, which takes out more time. So everything that we're trying to achieve with automated tests kind of get lost. So what can we do about it? Well, we can't get rid of the tools and the libraries. They're not going away. What we can do is refactor and abstract details. But it's really up to us. The tools will not do this for us. So let me show you an example. I chose another simpler application just for this example. So this is the application. It's a registration application. You fill in the first name, last name, email. You have to check that I have read the whole term sheet and agree. Checkbox, click the register, and it gets you to a thank you page. That's what it does, and this is the workflow that we're going to focus on. So when I started doing that, this is the test I generated first with Playwright's code generator. As you can see, it has a lot of things that are weird. First of all, the name of the test doesn't tell us anything. It uses to find the text boxes get by placeholder rather than get by role of text box. It has some redundant calls like clicking on the text box before actually filling it. So just out of the box, this doesn't seem excellent to me. Apart from that, part of the check that I want to do as well is call an API to get the information that it was actually saved, which the generator actually cannot do. So I wrote this test by myself, and it looks a bit better to me. I gave it a better name, more uniformity by using get by role for all the elements on the screen and calling them, and then there's the rest of the lines which calls the APIs, gets the response and compares the result. So far so good for a starting point, but like I said, it's not something that we'd like to have. So the next thing I would do to refactor is, instead of get by roles and checkbox and textbox and stuff like that, I'm going to hide it. So I'm going to move everything about the locators to a different file. So when I do that, the test becomes like this. So we now have get terms checkbox, get first name textbox, and so on. We kind of remove the details to another file that not contains all the functions that we want. That's okay, but we still have a lot of things. Basically what we have right now is reliance on the elements of the screen, like a checkbox and text box and stuff like that. It doesn't have to be checkbox and text boxes. It may look like that, but it could change and the implementation can change. And it doesn't make sense to have the test contain those. So I will rename those as well. I'm going to give them meaningful names. So instead of get terms checkbox and get first name text box, I will write it like check terms box and fill first name and fill last name and fill email. Again, abstracting details. Now, look at the arguments that I'm sending. The arguments that I'm sending could be anything, but it's not really anything. It's something that are specific for the scenario that I'm testing. In this scenario, the first name and last name could be anything. But the email should be a valid email. And I don't see it from here. So let's rename or extract constants and to another file and rename them to keep hints for ourselves. So when next time I'm going to look at it, I'm going to understand what the intent of running this test is. So I rename those to any first name, any last name, and valid email. So the thing that I prefixed with any tells me that I could send whatever I want in there. But the one with the valid email tells me don't change that to anything. It needs to have a certain pattern. Again, I try to keep hints for myself in the future when I look at it, so I'll know the intent, the purpose of this scenario. Okay, most people will probably stop here. Not me. Think about it this way. Am I actually checking the terms box, or am I actually agreeing to the terms? Because that's what a user does, right? So instead of just doing like technical stuff, let's call these functions with the actual intent of the user. So let's tell the story. It can look like this. So I'm still starting with goto, but then I'm agreeing to terms. First name is, last name is, email is. I'm submitting instead of clicking register. And then I display thank you with any first name, and evaluating the API request with last saved entry should include. Now, if you're familiar with the page object model, you know that this pattern does basically the same thing. We kind of collect all the local details, the technical details, into page object or classes or modules, and give them interfaces that express the intent. So the same thing I can do, what I did until now, only with page objects. And it will look like this. So I have a page factory, the one that is creating the pages, although I may not need that. And once I have a register page, I agree to the terms and first name and last name and email is, and then I submit to the register page, which gives me a thank you page, and on that I can check the display as well. So this tells me an extra step because it kind of tells me which pages I'm going through my story. So what can we do? First, we need to understand how code generators work. what kind of code they generate, and what they can do and what they cannot do. Then we need to create adapters. We did that with functions or page objects, whatever you think are good adapters to abstract the details so we won't see them in the test, and give those abstractions a better name, a better interface, so when we read the test, we'll understand what it's doing, what its purpose is, and what's the intent. The final thing that we need to do is segregate. What we need to is decouple languages. So what we'll have is when we have a module, it will speak in a single language rather than multiple language. Confusing one. So don't let monsters roam around testland. We have other bigger problems to solve. Thank you. This is what I want to share with you today. If you have comments, find me on social networks or on the site and let me know what you're thinking about this. And go watch this video. And apart from this video, I'm doing a lot of videos and webinars you can watch on YouTube as well. I want to thank you again for listening and hope to see you soon somewhere on the internet. Bye bye.